Hi, hi everybody. Today in geometry we're going to start looking at the area of a circle. So we've just studied about how to find the circumference of a circle, how to find arc length. Today we're going to start looking at areas dealing with circles. Let's do a quick review here on the circumference of a circle. The circumference of a circle we know to be pi times diameter, or 2 pi r. What is the area formula for a circle? A equals pi r squared. Okay. Now, in this video, I'm not going to get into why that's the area formula for a circle. We're going to do that at a different time. But here's our area formula, pi r squared. So circumference, 2 pi r. Area, pi r squared. Notice, they contain the three same items. They both contain a 2, they both contain a pi, and they both contain an r. Okay, what happens sometimes is that when we're working with circumference and then we're working with area and then we're switching back between circumference and area problems, students tend to get the formulas goofed up. And I see things like this. Okay. Is that the area formula for a circle? No, it's not. Okay, what have they done here? They've combined the formula for circumference with the formula for area. Area is pi r squared. Circumference is 2 pi r. So how do I keep these straight? How do I remember that pi r squared is area and 2 pi r is circumference? My little thing that I just think about real briefly is the units. If I'm going to measure a circumference, that's a distance. That's a distance around the circle. That's a length. Okay? So my units for circumference might be feet. But now when we talk about area, what are the units for area? Well, if the radius is given in feet, the area is in square feet. This is how I remember that the area formula is the one where the radius is squared, because our units are in square feet. So please do your best to keep these two formulas separated in your mind. Pi r squared as the area, square feet, r squared. Circumference is 2 pi r. All right, so let's find a couple areas. Okay, let's find the area of this circle. Okay, area is pi r squared. So this is going to be pi times the radius of this circle is 4.2. So pi times 4.2 squared. Put my calculator, here it is. Okay. I'm going to square the 4.2. We've got 17.64 pi as the exact area of that circle. Okay, and our units for that would be square meters. Yes, if I wanted to approximate this, I could type in 17.64 pi on my calculator. I'm not going to do that in this video. All right, how about the area of this circle? Area, pi r squared. This is pi times, what's the radius? Is the radius 9? No, the diameter is 9, which means our radius is 4.5. This is pi times 4.5 squared. Typing 4.5 squared in my calculator gives me 20.25 pi square centimeters. That's our exact area. All right, continuing on. Find the diameter of the circle if the area of the circle is 201 square inches. Okay. Notice the information that was given. The area of the circle, I know I forgot the word is there, is 201 square inches. Okay. Well, what do we know about area of circles? Area is equal to pi r squared. 201 is going to go in for the A. Now we're trying to find diameter. Our formula for area does not include the diameter, but if we can find the radius, can we find the diameter? You bet. So how do I solve this for r? I have pi times r squared. As we work to isolate the r, to solve for r, the first thing that we have to take care of is this pi. This is pi times r squared. We need to divide by pi on both sides. 201 over pi is equal to r squared. Next step in solving for r, I have r squared. I need to remove that squared, so I am going to take the square root of both sides. The square root of 201 over pi is equal to r. That's the exact radius. Now let's go back. We want diameter. If the radius is the square root of 201 over pi, what's the diameter? We know we have to double it. 2 times the square root of 201 over pi. What are our units on that? Well, the area was given in square inches. The diameter is a length, so this is 2 times the square root of 201 over pi inches. Good. Oops. Let's go here. All right, find the area of the shaded sector. That's probably a new word for us. What is a sector? Take a look at this diagram and guess what I'm referring to as a sector. That's this region right here. We need to go back to our vocab here for a second and define what a sector is in case you forget that word next time you see it. What is a sector? Well, let's draw a picture. Okay. We've got a circle. Okay. Okay. Looking back at this one, this region right there is a sector. How is that region defined? It's defined by this arc length, okay, that arc, and then it's defined by these, which are 2 radii. Okay. So if we draw our picture, let's draw in the radii. Let's draw in the arc. That is a sector. It's like a slice of the pie, a slice of the pizza. The sector of a circle is a region formed by 2 radii and an arc. Now we want to find the area of it. How do I find the area of a sector? Well, this probably should get you thinking similarly to finding arc length. How did we find arc length? Let's flip back here. Right here. How did we find arc length? Okay. We realized that the length of the arc right here, it was just a fraction of the what? Of the circumference. We said that arc length is the fraction. How did I figure out my fraction? I used this angle, x out of 360 of the circumference. Okay. So when we find the area of a sector, the area of the sector is just the fraction of the area of the circle. Okay. How do we figure out the fraction? Well, again, we need to know our central angle, x degrees out of 360 degrees of the area of the circle. So the area of the sector is equal to the fraction of the area of the circle. Now, if we want to take this one step further, this is x over 360 times, how do we find the area of the circle? Pi r squared. Same technique as arc length, except for a fraction of the area of the circle, not a fraction of the circumference of the circle. All right, let's go find that problem. Here it is. Find the area of the shaded sector. Well, what fraction of the circle do we have? 63 degrees out of the 360 degrees. Now it's the area of that sector is a fraction of the area of the circle. What's the area of the circle? Pi r squared, so pi times 5 squared. All right, 63 over 360. I believe we can reduce both of those by 9. Yes, we can. We've got 7/40. Right? Divide by 9 is 7. Divide by 9 is 40. Pi times 5 squared is 25 pi. Okay. I can keep reducing because this 25 pi is really over 1. 25 and 40 reduces. 5 goes into each of those. This is 5, and this would reduce down to an 8. So what do I have left in my numerator? 7 times 5 pi, 35 pi. My denominator is 8 times 1, which is 8. 35 pi over 8 is the area of our sector. The units weren't given, okay, so I'll just say this is square units. Very good. I like when things make sense. I like how this matches up so well with what we were just doing with arc length. Find the area of the unshaded sector. Yeah, here's the shaded sector. Where's the unshaded sector? It's all that, isn't it? That's still a sector. It's still formed by an arc and 2 radii. How do I find the area of that? Well, what's our fraction? How much of the circle do we have? Well, this was 106 out of the 360, so what would this be? Let's see, 360 minus 106, 254 degrees. So we've got 254 degrees out of 360 degrees. Now that's the fraction of the area of the circle. What's the area of the circle? Pi r squared, pi times 9 squared. All right, I'm going to have to search a little bit to see how this one reduces. 254 over 360. Okay. Well, both just divisible by 2. 127 over 180 times pi times 9 squared. That would be 81 pi. Now I notice right away 81 and 180 are both divisible by 9. So if I divide this by 9, I get 9, and if I divide this by 9, I get 20. In the numerator, I have 127 times 9 pi, so that's 1,143 pi. My denominator is 20. The area of the unshaded circle, 1,143 pi over 20 square feet. Good. All right, find the area of the circle. Okay. Now, what do we know in this one? Can we figure out the fraction of the circle that we have? Yes, we can. We know the area of the sector is 22 square meters. Can we find the area of the entire circle? Well, what do we know about the area of a sector? It's a fraction of the area of the circle. Okay. So let's replace the area of the sector with 22 equals, what fraction of the circle is this sector? 45 out of 360. Okay. Of, what do we do? What have we been doing? We've been taking the fraction times what? Pi r squared, because that's the area of the circle. We take a fraction of the area of the circle. So instead of writing pi r squared here, what do I want to find? I want to find the area of the circle. So I'm just going to leave that as the area of the circle. Okay. The area of the sector is equal to a fraction of the area of the circle. I don't need to know the radius to find the area of the circle. Take a look at this. We've got 22 equals 45 over 360 is 1/8. Okay. So 22 is 1/8 of the circle. To solve for the area of the circle, multiply by 8 on both sides. (176 square meters is the area of the circle. Right? Can you see that this is 1/8 of the circle? So to find the area of the circle, we need to multiply 22 by 8. Very good. All right. Okay. Day 1, finding areas of circles, finding areas of sectors. I hope we've got it. Let me know in person if you have any questions. Thanks for tuning in.